Okay, so one of the first things you're going to need to do when you're wiring up a circuit is to actually be able to cut the wire. Cutting the wire is, you can use a number of different tools in order to cut the wire. You can in fact use something as simple as a pair of scissors with this wire, and these, as you see, these will easily cut through it. You could use the wire strippers that we have available in school. You just need to use the bottom part here, not the indented part, just the bottom bit there. Again, just put that in and snip. See that will cut it quite easily. These are some alternative wire cutters that you can get from a hardware store. It tells you that you need to use this part here where it says wire cutter, and this will cut the wire again relatively easily. And also you could use a pair of pliers. You need to use this bottom part here of the pliers, and you just place the wire into the pliers, and again put the pressure on and you'll cut the wire. So whatever you're most comfortable with, you can use for that. Okay, so the wire has the metal on the inside, and then a plastic insulation around the outside of the wire. Okay, I don't know if you can can't see that very well, but so in order to connect one wire to another wire, or to connect a wire to a component, we need to remove the plastic insulation from the end of the wire. With the wire strippers or wire cutters that we have in school, you need to use the indented part of the wire strippers that's just here. You have to apply pressure so that you can go through the plastic sheath without going through the wire itself in the middle. So if I put too much pressure on, you can see that I'm going to cut straight through the entire wire. So I need to put enough pressure on so that it cuts through the plastic without going through the metal on the inside. So I'll just put a little bite in there. I'll just turn this around 90 degrees and put another little bite in at the same point. Okay, so I can now see an indent on my wire. It's this indent that I want to then grab, again not putting too much pressure on so that I don't cut through the entire wire, and then by pulling the wire away, you can see that the plastic sheath comes off, which I can dispose of, and this exposes the internal wire, the metal wire inside. Alternatively, you might choose to use these wire strippers. We don't have these available in school, and in order to use these, we use this part of the wire stripper here. You need to either use trial and error or know the gauge or thickness of your wire in order to use this. I know that the gauge of this wire is 1, and so I'll place this wire not into the 0.75, into the 1 that is there. Okay, and then because it's got a hole in the middle, if I then press together with a large amount of pressure, it's only going to cut through the plastic. It's not going to cut through the wire as well. Then if I pull the wire from the back, you can see that it's taken the piece of plastic off the wire, and it's exposed the internal wire so that we can then use it in the circuit in order to connect it. Okay, so when you're wiring your circuit, you may need to connect two pieces of wire together, or a piece of wire to a component, such as a light globe. To connect the two pieces of wire together here, what we need to do is we just take the wire, and you can see it's made up of lots of strands. We just twist all of these strands together to just give us one twisted strand of wire. I need to do this on both pieces of wire, and then we just twist these two pieces of wire together so that they connect. Now that should give a good connection, but if we do pull these two pieces of wire apart, they will lose that connection, and this would be a problem in our circuit. So just to give it a little bit more strength, what we can do, again, I'll just connect these two pieces of wire together, just twisting, making sure that it's metal on metal. We're twisting the two together. Okay, so once we've got that connection, you can then just use some electrical insulation tape, a small piece of this, and just connect over the top of the connection. This will make it less likely that it will come apart, and it also insulates that exposed wire from the environment. Okay, so now we can see that there's a stronger connection, and it's insulated too. We needed to connect it to a component. Okay, again, we take the wire and we twist the separate strands of the wire together. With the light globes that we have in school, we've got two terminals where the wire can be connected, and you're going to need to connect both of those terminals in your circuit. In order to connect the wire here, there's a hole in the middle of these terminals, so we just need to thread the wire through the hole and then fold the wire back down upon itself, and then twist the wire back upon itself. Okay, so we can see that connection there. That connection is a little bit loose at the moment, so a good idea might be to get some pliers, just using the tip of the pliers and just squeeze that wire down onto the connection, and that gives it a much better connection. Okay, again, we might choose to use a little bit of insulating tape just to shore up the connection and to insulate that connection there. And as you can see, there we go, we've got a good connection on that light globe. Another component you may use could be a battery pack. You don't have to use a battery pack, you can use an alternative source of energy for your circuit. Just need to strip the insulation off the end of this wire so that we can connect it. Okay. Again, just twist the separate strands. And then we can connect these together. Okay. Making sure it's, oops, let's do that one again. Making sure that it's metal on metal connection, the metal of one wire to the metal of the next wire. Twist those together. And then again on this one, we'll just twist. You can see as soon as this metal touches, we get a connection, and you can see the light there sort of flickering on and off, and that's because we haven't secured this connection. I'm just going to fold that back over, twist that wire around, and we can see that the light globe now stops flickering. And then it might be a good idea to insulate both of these points here to finish that circuit. Whoops, to complete that circuit that we have there. Another component that you may need to use is a crocodile clip. So to connect with the crocodile clip, we need to take our wire, again, just twist the wire so we get it one single twisted strand of the wire. And then take the crocodile clip and loosen this screw that is on the back here. Okay, we then need to thread the wire into the back of the crocodile clip. It's a good idea to just have a little kink in the end of that wire, so that when you get it through the back of the crocodile clip, it will then bend upwards and come through this hole here. Okay, so it comes through this hole that's here. When it comes through that hole, just need to pull it through. Okay, and so then to make sure we have a good connection, what we do is we take that exposed wire and wrap that wire around the screw. Make sure as you're looking down on the screw, you're wrapping the wire around in a clockwise motion, so that when you then tighten the screw, which is clockwise, it will then pinch down onto that wire. Okay, and that will give you a nice firm connection between the wire and the crocodile clip. Okay, sometimes we might want to connect components without using wire. So for example, if I wanted to connect this resistor to this LED, the point of connection is quite a rigid wire, and so in order to connect these two pieces of wire together, we can't twist like we did with in the previous examples. We have to use some solder to connect these. Okay, so solder is a type of metal, quite a flexible soft metal with a low melting point. So we use a soldering iron. You can see here the soldering iron. The tip of the soldering iron gets very hot, and then this can melt the solder, and then we can use this melted solder in order to connect the components together. So if I just place the components together next to one another, heat up a little bit of this solder on the end of the iron, and then put it on the two components. And then allow that to cool. Then you can see that we can connect those two components together using that that solder there. Once it's completely cooled, you could also wrap a little bit of insulating tape around there just to ensure that connection stays together. Another component that you need to connect into your circuit is a switch. This switch that I have here is actually a two-way switch. So we have the central position, which is off, and then we can turn it on one circuit that way, and then turn it the other way for another circuit. So if we look behind, we've actually got quite a lot of terminals that we can connect to. Effectively, we need to, in order to create just a simple circuit, we need to connect to one of these middle terminals, and then to connect to one of the terminals on either this side or this side, depending upon which way we want it to turn when we switch it on. So when you get your switches, they may be very different to this. They may just be switches with two positions rather than three, like this one, and a simpler arrangement at the back. But ensure that you know how your particular switch works before you finalize your circuit. So to connect this one, again, these terminals on the back have got holes in them. I don't know if you can see that. Okay, the terminals in the back have got holes in them. So just need to take the wire that we're using and then thread the wire through the hole, and then fold it back over itself and twist the wire back on top of itself, so we get again a good connection. Might just pinch that wire onto the terminal so we get a good connection there. Now it would be hard to put insulating tape around this at this point because it's very small, the terminal. So what we might do again is just use a little bit of solder just to ensure that our connection remains, doesn't come loose once we put it inside our building. So we just need to heat up the solder. Oops. Soldering iron's just warming up. Heat up the solder. Get a little bit of solder on the end of the soldering iron and place that onto the terminal. Okay, so we can now see this connection here with a bit of solder on it. It's a much better connection. It's not going to come loose or come apart.
You could just reach up and get it.
Okay, so if I just show you this circuit completed again, what we need to do is we need to strip wire, okay, twist wire, and then put wire together by twisting the two wires together here. Making sure it's a good connection and insulating it with some insulating tape. Adds a little bit of strength, ensures that it's sufficiently insulated. And then it can connect this wire to one end of the resistor. Okay, so I'll just wrap the wire around the resistor here. Of course I can't wrap the resistor around the wire, so I'm just going to add another little spot of solder to make sure we get a good connection. And one final piece of wire just to complete the circuit. Twist that piece of wire. Twist that piece of wire. So again, I can just twist this piece of wire around, this time the LED. Okay, and just to ensure that it doesn't slip off, again, a little spot of solder. And then finally, to complete my circuit, I need to attach it to the switch, into this central terminal here. It's important that it doesn't touch the wire over the next terminal. Again, twist it back round. Sure it's a good connection with a little spot of solder. And there we have the complete circuit. See it, the light coming on, and the switch is turned from the off position to the on position.